Hello everyone, welcome back to, actually, this is the first video on our SHS Math Team YouTube channel. So, basically, I'm just going to walk through some problems, and that's kind of all we're going to do on this channel. But this is problem 2 from match 1, round 6, and it's 2018 to 2019. And of course, this is question 2. Alright, so the problem goes, let's underline by the way. So square ABCD, and keep in mind that it's a square, so when it says perimeter of 40, so perimeter is if you don't know this, it's basically the length of the entire outside. So, let's say this is side A, B, C, D. So when you add them all together, A plus B plus C plus D equals 40. And in this case, when we say that it's a square, it means that A equals B equals C and D. So essentially, you can just say, for example, 4A equals 40 because they're all the same. And now we know A equals 10, and therefore A, B, C, and D are all 10. Now, that's kind of the type of thing that you'd have to do in your head probably, and it's not too difficult, but I just did that there for demonstrative purposes. Alright, let's continue. So point A has coordinates 8, 3. So let's draw our diagram. So horizontally is the x-axis, and then y-axis is vertical. Don't bother to draw the arrows, by the way. There's really no point in doing that. And you usually won't need to do the tick marks, because roughly it's you just need a rough idea of where everything is, and then you should kind of use differences in the distance rather than kind of trying to figure things out just by looking at it. So we'll see an example of that in this video. Alright, so point A has coordinates 8, 3, so it's 8 to the right and then 3 up. So I would say, around there. And let's label that A. And point C has a y coordinate of 5. Now, for our square here, we're not going to want to use the sides as the letters. We're going to want to use the corners as our labeling. Whoops. Okay, so A, B, C, D. Now, notice that A and C are opposite from each other. So, that should be kind of important to know. So the opposite corner has a y coordinate 5. So if you recall, 3 is over here. So 5 should be, around there. And so it says that point C has a y coordinate of 5. Let's also label the 8 there. Alright. So y coordinate of 5, we can do a dashed line for that, because we don't really know where it is. Alright. Next is the actual problem. Find all possible equations for the diagonal that passes through the points B and D. Now we have B and D going like that. So it's basically we know that actually immediately that these are all right angles, because it is a square after all. And squares have, if you draw through the diagonal, they'll have the 90-degree angle on all sides. And that also means that we have perpendicular lines. So actually, how would you prove that all of these are 90-degree angles? Well, let's see. So since all 4 sides are the same length, when you draw a cross through the middle, you're going to get both lines, both diagonals, being the same length due to the Pythagorean theorem. And by the way, let's try to find the length of that diagonal right now, or both diagonals. So this is 10, and that's also 10. So CD, BC are 10, and then that means that BD, that line segment, equals 10 squared plus 10 squared square root. And that means that it's square root of 200. Now, in most problems, you can usually keep the square root. It really probably won't really do much harm for you if you do simplify it. But that's if you're pretty good at doing that in your head. So here, I can kind of easily tell that the 2 zeros here means that we can pull out a 10 and then leave the square root of 2 inside. So that was very quick. So I would kind of actually do that. All right. But for a lot of problems like involving triangles, you probably do want to keep the unsimplified form like that. But we can use both now that we have both, of course. All right. So at this point, we need to basically just find where C could possibly be. And to do that, we can notice that, well, A and C, what is the length there? We just figured it out. And this is also equal to length of AC. Alright, so the length of this diagonal, basically, well, I guess I haven't finished reading the problem yet. That's important. So find all possible equations for the diagonal that passes through the points B and D. So it's the equations, not the actual points for B and D. So that's something to note. And let's see. So where could C be placed? Well, we know that it has to be on a y value of 5. So, like anywhere there could be, potentially the answer. However, we do have a constraint, right? We have a constraint on where C could be because we have this limiting length of 10 square root 2 for the length of A to C. So if you imagine kind of like a circle, perhaps, I'm not good at drawing circles, but I don't know. Oh, goodness. Alright, that's good enough. So maybe like you're not good at drawing circles, but you can also think of it like you have a stick that's, that long, 10 root 2. You have a stick that long, and you can kind of swing it left and right, kind of like on the axis, with like A as an axle. You can like swing it in a circle or in an arc. So that point C will have to kind of land on only 2 places, because if you think about like a windshield wiper, if it goes left, it can only hit that y coordinate equals 5 line at one point on the left, right? You swing it down there somewhere, and you swing it down to the right somewhere over there. So there's only really 2 places it could be, to the left and to the right. Now, how much is it going to be left and right by? So really, like, what's the kind of x movement factor there? We don't really know. But what we do know is the distance is going to be square root of 200 for both. And I'm just going to kind of work on the left one, because anything we do on the left, we can mirror to the right. Alright, so we have square root of 200 as the length of this kind of line there. And that could be a point for C. Let's label that. Alright, so what I'm kind of noticing here is that the y differential here between A and C is actually going to be 2, between 3 and 5, of course. So we have that 200 there, the square root of 200, and we have 2 on the left. Now, if this kind of reminds you of anything, I know it does for me, so this kind of reminds me of basically, let's see, well, there's kind of like this diagonally going thing like that, and there's a vertically going thing. So if we had a horizontal right there, that would make it a triangle, and in fact it would be a right triangle. So I know that was kind of like I just pulled it out of my imagination, but I guess some things in Math Team you do actually have to kind of just imagine it and then it works out. But basically, now that we have this right triangle, it becomes very interesting because we can use the Pythagorean theorem. So 2 squared plus this bottom side, let's call it L squared, equals 200. And this is the good part about keeping it in this form, unsimplified, because then we can square it in case we do have to use the rule with right triangles, Pythagorean theorem. In that case, we get to just simply remove the square root. Alright, so 2 squared is 4, subtract from the right, we get 196 equals L squared. Now, this is something you should actually memorize. I should probably write this down somewhere, but basically, you should know all of the squares of all numbers up to, for example, 20, let's say. So that's a good kind of threshold to have. So that will really help you with like these types of things where you don't really know the square root, but what is it? So in this case, it is an even number, so you could just keep on dividing by like maybe like 2 and see where that gets you, like do prime factorization. But for me, I kind of just know that 196 is 14 squared. So L is 14. We have 14 on the bottom there. Now, how does this really help us, though? How are we going to know the diagonal equation that passes through points B and D? Well, if you recall that we need 2 things for an equation. We need a point on the line, so we need a point, and we need the slope, right? For a point-slope form, and if you don't know that, it's y minus some point, and then the y value of a point, that equals m, the slope, times x minus 1 x value. And now these have to come from the same point, right? Alright, so to use this equation, we need the slope. So what is going to be the slope of the diagonal passing through points B and D? Now, I can actually draw kind of how it would look. So if we try to draw a square with 45-degree angles there, so that square, right? You can tilt your head a little bit to the left to kind of see it. But so basically, in this case, it's going to be making a 90-degree angle with our line that goes from A to C. But also, we kind of are reminded of that right here. So it makes a 90-degree angle, and the thing about perpendicular slopes, right, is that if you have a perpendicular slope, it's going to be the negative reciprocal of whatever slope you're perpendicular to. So basically, let's try to find the slope of the line that goes from A to C. So there, we actually do have like the exact diagram. So it's actually negative 2 as the rise, and then 14 across as the run. So we have that equals negative 1 over 7. And we need the negative reciprocal equals to 7. So now we have the slope for our line. But what about a point on this diagonal? Well, if you think about it, we actually do have a common point between AC and BD. And that common point is the intersection in the middle. So it's the midpoint of both lines. And therefore, since we have A to C, we actually know we can actually just get the midpoint of B and D, which is a point on the BD line, the diagonal, with just the information we have about A and C. So to get the midpoint of that, we actually just need to kind of half this triangle. So cut the triangle in half vertically and horizontally. Or you can think about like cutting the line in half vertically and horizontally to get the midpoint. And so that would be kind of 1 up from point A and then 7 left from point A. So point A again is at 8, 3. So again, we said 1 up, so that's a y value of 4. And then we said 7 left, which is going to be 1. So 1 comma 4 is a point. I'm not going to plug it into the equation because that's kind of like... Oh, actually, I could just do that because it says give it in slope intercept. Oh no, that's the other form. That's annoying. So we can have point slope form. I'm not going to do the whole thing, but to plug it in, I'm just going to do this for demonstrating purposes. So y minus 4, because 4 is the y coordinate there on the point. And then that equals to 7. Again, 7 is the slope. We got it from the negative reciprocal of the perpendicular AC slope. And then times x minus 1. So this is point slope form. To convert this into slope intercept form, you would distribute the 7 to the x and the minus 1, and then you would move everything to the right side away from y. So isolate y, and that'll give you slope intercept form. Alright, now continuing, that's only half of the solution. And I know this took a long time, but basically you would have to do this pretty fast in the actual competition. But I'm just kind of walking through it slowly because that's kind of the best way to practice. It's not try to rush, but actually maybe think more about your actions, try to make the right decisions, and just take it as slowly as you need to, and think deeply. So we do have the left answer now, but what about the case in which C could be placed on the right there? So in that case, it's actually a very similar process. We can draw kind of the same triangle, just reversed or reflected. And I think there might actually be an equation that lets you reflect lines over, or reflect the equations of lines over the vertical line. But I don't really know that equation, so you could look it up, but it's kind of the same thing, just doing it again. And it actually will go faster this time because you know that the slope has to just be basically like, so the rise over run is just reversed. So the run is like the same, but the rise is the opposite. So the rise would actually be, 1 over 7, or it would be 1, and then wait, I say the, I mean the rise is 1, and then the run is 7. And you can get the negative reciprocal of that, and then do the same thing. Actually, now you don't even need to do the triangle anymore. You kind of just know what to do. But I am curious about the line reflecting problem, because I do remember seeing that a lot last year. So I think I'll kind of put that in resources somewhere. So along with memorizing the squares up to 20, I would also recommend checking out the line reflection formula, because that would be pretty useful. Let's see. Yeah, that's about it. Alright, thanks for watching, and see you guys next time.